For the independent samples t-test, we're looking at comparing two groups. And the formula shows you that you calculate the mean of group 1 minus the mean of group 2, so the mean difference here, over the standard deviation of group 1 squared divided by the sample size of group 1 plus the standard deviation of group 2 squared divided by the sample size of group 2. This whole term is being squared. So that will give you the t. Now how can you calculate this? Take the average of group 1, which is in here, and then the average of group 2, which is right here. Then we'll calculate the difference between the individual score and the mean, which here is negative 0.9, so this person is a little bit below the mean. This next person here is a little bit above the mean, so we do this for every person. Note that we use for group 1 the mean of group 1 to calculate the difference, and for group 2 we use the mean of group 2 to calculate the difference. Then this term here is the difference squared, so we get rid of all the minus signs, it's only positive values, plus we emphasize the distance, so scores that are below 1 get a little bit smaller, right? And scores that are above 1 when they're squared get bigger. So 5.9 becomes 34, whereas 4 is only 16. Right? We add all these up. This gives us, we add all these up for group 1, gives us the square difference, the sum of the square differences of group 1. This here gives us the sum of the square differences of group 2. I'll use this to calculate our variance. So the variance of group 1 is the sum of the square differences of group 1 divided by n minus 1. So this is the sample statistic. And then the standard deviation is the square root of the variance. The standard deviation squared is the variance. Now this is the long, and we do the same thing for group 2. Now this here is the long way. I explain you exactly how we come about with these values. But there's also a fast way in Excel, just as standard deviation, and we want this for group 1. And then the fast way for the group 2, same thing, standard deviation for group 2. Now we have all the values that we need to plug into our formula. We plug this into our formula here. So the mean difference is the term on top. The pooled variance is this term on the bottom. So we get the standard deviation of group 1 squared right here, divided by n, it's 10. Plus the standard deviation of group 2 squared divided by 10. So right here, and we take the square root of this term. So then to get the t value, it's the term on the top here divided by the term on the bottom. That gives us a t value of 1.99. Now for the degrees of freedom, it's n minus 1, 10 minus 1 plus n minus 1. So the two groups. Now to get the probability, you can calculate 0.0. You can either use this formula from the Excel Ttest. We specify the values for group 1 in blue up here, and the values of group 2 in green. Then we decide how many tails. A 1 for one-tailed, and you type in a 2 for two-tailed, and then the type 2 means the independent test, type 1 means the dependent test, paired samples test. So here, the same formula, but you note for the tails we have a 2, so this is the two-tailed significance. And then you can interpret this values above 0.05 or indicators that we do not reject the null, and if the value here is below 0.05, 0.5 or below, then we reject the null. So in this instance, for the one-tailed test, we would reject the null. For the two-tailed test, we would not. So if you want to use real statistics, you go use the data analysis tool, Ttest. We have to specify the range. For group 1 it's B2 through B11. For the second group it's B12 through B21. We don't want the column headers. We want it to be 2 independent samples, and we're gonna enter this in column A71 with OK. Now we can go look down here and see we got these values, and we check the t statistic 1.99, same thing that we got up here, and for the significance the p-value is 0.03 and 0.06. Then this also makes the decision for us: significance yes or significance no. You can see that there's a logic here. It says if the blue cell, the p-value is smaller than the green value, so if the p-value is smaller than 0.05, then you enter yes, otherwise no. So a logic is implemented here.